Okay, so we are on Unit 4, and this is the first lesson in Unit 4. This lesson has quite a bit of vocabulary because this is probably a new concept for a lot of you. So we're going to talk about a new type of function called a quadratic function. And these vocabulary terms are mostly for you to know what I'm talking about when I use the words parabola, vertex, axis of symmetry, maximum, minimum value. So that vocabulary and those flashcards are important. And I want you to know that going in and really reading over those and seeing images of them, I think helps. So if you're taking these notes in a notebook, it's going to be hard to graph using a notebook. So if you want a paper copy, I know that we're virtual right now, let me know and I'll get that paper copy to you. If I have to drive to your house and drop it in your mailbox, I will do that. But let me know, reach out, speak up. I am not going to be offended if you ask for those things, all right? I will give you those things you need to succeed in this class, okay? So starting off, we're going to talk about the parent quadratic function. And this is the most basic quadratic function that all other quadratic functions are formed from. So the parent function for the family of quadratic functions is the function f of x equals x squared, right? That is the most basic quadratic function. And that function forms a graph that is U-shaped. That U-shape is what we call a parabola. Okay, and that parabola has some important features. One of the important features is this axis of symmetry. And the axis of symmetry, sorry about that. The axis of symmetry is basically an imaginary line that splits our graph in half, all right? It splits our graph in half. That is the axis of symmetry. So the axis of symmetry for this parent function would be x equals 0, vertical line at 0, right? And then the lowest or highest point, the maximum or minimum value, is called the vertex. The vertex for this parent function is at 0, 0. That makes it a minimum value. It has a minimum value of y equals 0, okay? So its minimum is 0. So that's some of the basic features of a quadratic function. We are going to use Desmos for a lot of stuff to graph, but I still like you to know how to graph some basic things by hand so you understand the symmetry, the maximum, minimum, those things. So when we get to example 1, and I'll erase this little skid mark here. I already graphed the parent function, as you can see there. Now what I want to do is I want to graph this function, and we're going to compare it with our parent function graph. So we're going to graph y equals negative 2x squared plus 2. So there's a couple important features we've got to know here. And this kind of comes back to transformations of functions. So one thing is this graph, I'm going to compare it first and then I'm going to graph it. So this graph, first of all, with that negative value, that value negative 2 on the front, that means the graph opens down because it's a reflection, all right? So we know it's going to be an upside down U shape from this negative 2 on the front, and that value of 2 times x squared means this graph is going to be vertically stretched. And then the last thing, the plus 2 on the end, means it was shifted up 2. So some basic transformations there. Now, if you're ever in doubt with how to graph something, what I usually do is I make an XY table, and I choose values that are showing up on the graph. So I usually pick smaller values. So let's just pick values like negative 2, negative 1, 0, 1, and 2. So I'm just picking inputs. When I substitute those into my function, I'm going to use order of operations, plug in x. If I plug in negative 2, I get out negative 6. If I plug in negative 1, I get out 0. If I plug in 0, I get out 2. If I plug in 1, I get out 0. I plug in 2, I get out negative 6. So you kind of should see the symmetry here, but we graph these points. Let's look. Negative 2, negative 6 is going to wind up down here. Negative 1, 0, 0, 2, 1, 0, and then 2, negative 6. So if we look at it, we see the symmetry there. It's going to be an upside down U shape, and I'm going to do this terribly, but it's going to be an upside down U shape that passes through these 5 points we had, and we should see it opens down, check. It's vertically stretched. It should look a little bit skinnier, and our vertex is basically shifted up 2. So that's an important thing. So I want to go over a couple of the important features here. The first thing, the axis of symmetry of our new graph. Our axis of symmetry is x equals 0. All right? Our axis of symmetry is still that y-axis. Our vertex is the point 0, 2. And that is a maximum value. It's the highest point on the graph. So those are the big things I want us to know how to do. If you are ever in doubt with graphing by hand, make a table of some, I call them simple values. That's a kind of a point of view thing, but I pick values that are basically small, close to 0, right? -2 to -2 is usually pretty safe. So I want to talk a little bit more deeply about properties of this function when we're graphing it, okay? So in these functions, the standard form is ax squared plus bx plus c. A and b are coefficients, all right? They determine some things. A determines the skinniness, the width of the graph, okay? The b value kind of shifts around the graph. C moves the graph up or down, okay? So A really controls whether it opens up or down and the width of the graph. That's what A controls, okay? C controls if it's up or down. So our graph opens up if A is positive, and it opens down if A is negative, all right? So that first coefficient, the value being multiplied by x squared, determines up or down. Makes it narrower if A is bigger than 1, okay? So if A is like 2, 3, 4, any number larger than 1, and it's wider if A is between 0 and 1, meaning if A is 1/2 or 1/3 or 0.5. If it's any of those values, it's a wider graph than the parent function. The big thing here is this axis of symmetry and this little equation, all right? Our axis of symmetry comes from this value -b divided by 2a. And it just so happens that the axis of symmetry is always the x-coordinate of our vertex. So when we find our vertex, we find the axis of symmetry, and then we plug in that value for the axis of symmetry to find the y value of our vertex, and I'll show that. And then the y-intercept is always c. So we've always got a point kind of given to us. The y-intercept is always that constant at the end. So for an example, in example 2 here, graphing a function in this standard form, there's a couple of things that we're going to get right off the bat here, okay? One thing I'm going to do is I'm going to understand that my y-intercept is the point 0, -3. And that comes from that -3 constant at the end. So really, if you want to, you could graph that point right away. I know that's my y-intercept, okay? That's the thing I always pick out first. I think that's the easiest thing to find. Now, the next thing is to find our axis of symmetry. And you're going to see me use the letters AOS, like LOL, just an abbreviation, that's all. So AOS. So our axis of symmetry is that x equals, that line x equals -b over 2a. So it might be a helpful exercise to, at the beginning, identify in this function that a is -1, b is 4, and we already said c was -3. So if I find -b over 2a, that's going to be -4 over 2 times -1. All right? And then this becomes -4 over -2, which is 2. So our axis of symmetry is x equals 2. So that's a vertical line at 2. And I just make it a dashed line to make it a little less confusing when you look at it, okay? Because then it's not a solid line that's screwing up our parabola, okay? So that's an important thing, because the axis of symmetry then allows us to find the vertex. So we got to find our y value of our vertex. So our y value of our vertex is the result of us plugging in our axis of symmetry. So this becomes -2 squared plus 4 times 2 plus, or sorry, minus 3. So this becomes 2 squared times negative 1, that's negative 4, plus 8 minus 3. So I simplify that out. That is going to be 4 minus 3, which is 1. So our vertex is the point 2, 1. Oh, dropped my pen there. Sorry, guys. 2, 1. All right? So I'm going to graph my vertex. 2, 1. And the way you can tell if your vertex is the right point is if it lies on the axis of symmetry. Okay? So that's a good thing. So I've got my vertex. Now, for me to graph this, mainly what I want you guys to know how to do is find the y-intercept, find the vertex, and then use symmetry. Using symmetry means if I have a point that's right here, my y-intercept is 2 to the left of my axis of symmetry, another point is just reflected over that line of symmetry. All right? And then that's going to be my function. Graphed. Now when you're starting out with this, with graphing, I still want you to use Desmos to check answers. I encourage that fully. I still want you to know how to do some of the work to find these values and understand this is a maximum value. This is the vertex, this point, okay? This line is the axis of symmetry. I want you to know some of those features. That's what we're building right now. The graphing by hand is important for understanding the features. Long term, it is more important you know how to read and analyze graphs, okay? So the last thing I want to show you is how to find maximum and minimum values. So it's basically finding the vertex. So the way we find maximum and minimum values is we find the axis of symmetry and then we plug it in. Because the axis of symmetry is the x value. When we plug it in and we get out an output, that's the y value of the maximum or minimum value. So example 3 is going to be our last example we cover here. Example 3 has us find the maximum or minimum value of this quadratic. So the first thing I'm going to say is this quadratic is going to open, and I'll put a little thing up here, it's going to open down. Because a is negative 3. So it has a maximum value. It has a highest point because it opens down. All right? So that's how we know it has a maximum value. The way we find that maximum value is we first find our axis of symmetry. So again, that exercise of saying A is negative 3, B is 12, and C is negative 6, that might help because our axis of symmetry is still that negative b over 2a, which equals negative 12 over 2 times negative 3, which is negative 12 over negative 6, which is really 2. So what I just found here was my axis of symmetry and the x value of my vertex, two things at the same time. Now, to find the maximum or minimum value, to find that vertex, I'm going to box this off a little bit, and we are going to find the output when the input is 2. That's why I write f of 2, because I know I'm plugging in 2 for x. So this becomes negative 3 times 2 squared plus 12 times 2 minus 6. So this is negative 3 times 4 plus 24 minus 6, negative 12 plus 24 minus 6. That's really 12 minus 6, which in the end is 6. So y is 6. So this function has a maximum of 6. Okay? So this is going to take a little bit of practice to do. All right? It's a lot of things. It's a lot of words. It's a lot of new terms. So the practice is going to be fairly important here. For the practice, again, if you don't have a paper copy, I will do my best to get these unit notes and practices to you. Again, I can play mailman and deliver them to you. I have no issues doing that. You just got to be patient with me because I've got to teach and I've got to get materials out to kids if I need to. I think hopefully we'd let you come into school or come to school to pick up stuff, or if you send parents or somebody to here, I will print that off and get them to them, and I'll get that stuff to you. But you need to speak up and let me know. I will do everything in my power to get you all the stuff you need to learn so that this isn't a stressful situation, okay? Please, please, please communicate with me so that we can make this as seamless as possible. It's not going to be perfect, but I'll do my best to help you guys out. So you can move on to the next step in the lesson. Let me know if you need help with anything.